All right, typically when we graph trig graphs, we're going to start with the axes numbers because those are the easiest. So we would start with 0, pi over 2, pi, 3 halves pi, 2 pi. And just in case you didn't know, let's readdress that. This is 1, 0, and this is location 0. This is pi over 2, and this is the order pair 0, 1. This is pi, which is negative 1, 0. And this is 3 halves pi, which is 0, negative 1. The first number represents cosine, and the second number represents sine. X and y. X is my cosine, y is my sine. Do I have everyone? Everyone's good with that part. Okay, so what I'm going to do is I'm actually going to do this in 2 columns instead of 3 because I can easily multiply and I can easily add. It's asking me to multiply and it's asking me to add. So I need to find the cosine at 0. So 0 is right here. What is the cosine at that location? 1 times 2 plus 1, 3. Excellent. Now I'm going to move on to pi over 2, which is here. What is cosine at that location? Times 2 plus 1. Excellent. Now I'm going to move to this location. What's cosine? Times 2 plus 1. Negative 1. Okay? Now I'm going to move to this location. What's cosine? Times 2 plus 1. And my last and my first are almost always the same exact. The other thing is sine and cosine make like parabolas. They're symmetrical. So it's going to be balanced on both sides as long as I have equal spacing. Okay? Now, you always have to have 5 points. I have 5 points. If I do the four axes, it gives me the 5 points, right? Because 2 pi and 0 double up. So I'm going to go ahead and plot this. So 0, 3 is right there. Then I'm going to go pi over 2, and I'm going to have a height of 1. Then I'm going to go pi, and I'm going to go to a height of negative 1. 3 halves is back up to 1. Remember, I was telling you about that beautiful symmetry. And then 2 pi is back to 3. Don't make harsh edges. Sine and cosine are beautiful waves, so they're rounded. Cool? Okay? And if you wanted to, you could continue on the other side, but it is not necessary. As long as you have 5 points, I am happy. Good? Okay. Now, go back to number 1. On Friday, to make things easy, I changed the amplitude, okay? Or not the amplitude, I changed the period to make it 3. So that would be pretty. The reason why I did that is simple. If I did my basic 0 pi over 2 pi, 3 halves pi, 2 pi, it wants me to not multiply the answer, but multiply the angle by 2, right? 0 times 2 is 0. Pi over 2 times 2 is pi. 2 pi. 3 halves pi is 3 pi. And then 4 pi. Okay. If I found the answers to each one of these, so the sine at 0 is 0. The sine at pi is 0. The sine at pi at 2 pi is 0. What happens? It's all the same answer. It doesn't matter if that answer is 0 or 1. You never want, sine and cosine should not give you a flat line. Okay? So this is a case where the axes do not work. You cannot use the axes. Okay? So we're going to start fresh. Remember, we learned the hand trick. The hand trick has how many angles represented? 5. And I need 5 good points, right? The thumb is 0. The pointer finger is pi over 6, or 30 degrees. The middle finger is pi over 4, or 45 degrees. then pi over 3, pi over 2, okay? And those 5 angles show up in all 4 quadrants. All 4 quadrants have a 0, they have a 30, they have a 45, they have a 60, they have a 90. Yes? Good? All right. So now they want me to multiply each of these angles by 2. Remember, when you multiply a fraction by a whole number, you're really just multiplying the numerator by that number. So, first period hated it when I reduced the fraction, so I won't reduce. I'll tell you what the reduced is, but this becomes 2 pi over 6, which is 1/3. It doesn't matter if I write 2 pi over 6 or if I do 1/3, because when I switch it to degrees, I'm going to get the same answer. 180 divided by 6, 30 times 2, 60 degrees. So I'm going to look at 60 degrees. Here's 60 degrees, yes? Using the hand trick, your ring finger's down. How many fingers are up? 3. So this is the square root of 3 over 2. Yes? I skipped one. What's 0 times 2? 0, and we already know the sign of 0 is 0. Yes? Okay? Now, pi over 4 times 2 is 2 over 4 pi, or pi over 2. And pi over 2 is the north axis. Okay? And when I'm on the north axis, what sign? 9. No, what sign? 1. Sign is 1. Good? Do I have 3 different answers? Yeah. Okay? So pi over 3 becomes 2 over 3 pi, which ends up being 60 times 2, which is 120, which is also a 60-degree angle. So that brings us back to the square root of 3 over 2. And this last one's going to be what? Remember, it's symmetrical. It's going to be 0. So now I have beautiful points that I can plot. Now here's where it gets tricky. You're in honors pre-calc, so you should not be using calculators. Years ago, and I don't know where it is in the curriculum or if they still teach you this, you used to have to estimate square roots, right? Yes? So I have the square root of 3. 3 is between what 2 perfect squares? What 2 perfect squares? First of all, do we know what our perfect squares are? 1, 4, 9, 16. These are perfect squares. 3 is between what 2 perfect squares? 1 and 4. Okay? It is closer to 4. What is the square root of 4? 2. Again, we're estimating because we're making a rough sketch. Does everyone get that we're estimating? This is not an exact answer. Okay. So I need a number bigger than 1, less than 2, but closer to 2. Give me a number. Everyone goes right in the middle. Let's go. I like 1.8. Okay? I like 1.8. That's fine. I also did 1.6 earlier. Okay. So 1.8 is going to be our estimate of the square root of 3. Yes? What's 1.8 divided by 2? 0.90. Okay? So now I can plot, right? So I can put a dot at 0, 0, at pi over 6, which would be, so this is pi over 4 here. So this is pi over 6, this is pi over 3, okay? So pi over 6, I'm going to be very close to 1. Pi over 4, I'm going to be at 1, and then back down like that. So it's really scrunched close together. Does everyone see it? So that would have been the graph of sine 2 theta. Okay? I only have to use the hand angles, not the axes angles, if what happens? How do I know when I can't use the axes? When you use the axes, if you get the same output for every single one, you have to go break it to smaller angles, okay? Because you should never get a flat line for sine or cosine. Good? Okay? I don't believe I was mean on the quiz, and I think on the quiz, all of them you can use the axes numbers. Okay. All right, so let's move on. Flip your paper over, number 7. Okay? All right. There's my unit circle. If you need to, label correctly 1, 0, 0, 1, negative 1, 0, 0, negative 1. Awesome. And we always start with 0, pi over 2, pi, 3 halves pi, 2 pi. And I can multiply by 2 and add by 1 in my head, so I am not going to do 3 columns. I'm only going to do 2. Are we okay with that? Okay. So I am starting at 0. So the 0 axis is right here. Do I look at the x or the y? Why am I looking at y? Because it's sine. So the y value is times 2 plus 1. Excellent. And then I'm just going to move each axis. So I'm at this axis. What's my sine? 1 times 2 plus 1. 3. Excellent. Now I am at this axis. 0 times 2 is still 0 plus 1 is 1. Okay? And now I am here. Did I mess up something? No, okay. Negative 2 plus 1 is negative 1. And then I am going to go back to the start, and so I get a positive 1. Well, this one's not pretty symmetrical, huh? All right, sorry about that. All the other ones have been pretty and symmetrical, sorry. All right, it's still the pattern, though, the pattern for sine, which is 0 max, 0 min. 0 max, 0 min. All right, so at 0, I'm going to plot the ordered pair 1. At pi over 2, I'm going to mark 3. At pi, I'm going to mark 1. And then, oh, because I know why. Last time it fit because of the period. Okay. So then 3 halves pi is going to be negative 1. And then back up to 1. It's still pretty parabolas. Zoop, zoop, zoop. And we always have to have how many points? 5 points, and make sure you curve. It's a beautiful wave. All right, please go ahead and attempt. Yes, question. Yes, we're going to do negative out front. Yep, reflections. We're going to get to that. It's not scary. We're doing it today. Piece of cake. It's all the same process, guys. Okay? All right, please do number 8. If there's a negative, if there's a reflection, it's just multiplying by a negative number instead of a positive number. It's not a big deal. Okay, please attempt number 8. Okay, I always start with the axes, and then if my output's all the same, then I'll break it down. So I have 0, 0, pi over 2, pi, 3 halves pi, and 2 pi. Okay. Now, this one's a 3 column because I have a horizontal shift, a phase shift. So I'm going to take 0 and I'm going to subtract half. What is that? So negative pi over 2. I'm going to show you another way to do this problem in a second for those people that are a little more visual. Pi over 2 minus pi over 2 is 0. Pi minus pi over 2 is pi over 2. Then we end up with pi and 3 halves pi. We just shift everything down one location, right? Because it's already separated by pi over 2, so we shift everything down. Okay? Now I calculate cosine based on these angles. Okay? So if I am to go backwards half, that is here. What is the cosine of that location? 0. So my answer is 0. And then I continue going around the clock. So right here, it's going to be 1. Here, my cosine is 0. Here, my cosine is, what is it? Negative 1. And back to the green is 0. Everyone good with that? Is everyone good with that? Okay, so I'm going to stop. Okay, so you just have to remember that cosine is x and sine is y. That's how I got these answers. Another way to do it is in another class. This is backwards pi over 2. So all the student did was they went backwards in axes because each axis is pi over 2, 90 degrees, right? So they knew that they were starting here. So they asked themselves, what is cosine here? 0. So they didn't even do the middle column. They went 0 and they went around the clock. You can also do that. So if it was pi, I would go forward, and this would, if it was cosine theta plus pi, I would start here, right? And what's cosine here? -1. And then they go and do cosine at each of the axes. That's another way to do it. And you just have to go how many locations? How many I need 5 locations, okay? All right, so we're going to go ahead and plot this. So we have 0, 0. Hold on, let me close this out. Okay, then I have pi over 2 and 1, pi over 2 and 1. Then I have pi back to 0. Then I have 3 halves pi and -1. And then 2 pi is back to 0, making a beautiful wave. La, 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 la. Done. Good? All right, so continuing on, number 9. Number 9 has a phase shift and a vertical shift. I personally would do 3 columns, or you can change your startup. Either way will work, okay? You can change your startup. So go ahead and attempt number 9. All right, I'm going to show this one using both methods, and you need to find a method that works for you, okay? So the first method, I would need 3 columns. I start with my 0, pi over 2, pi, 3 halves pi, 2 pi, and I have to increase it pi. Okay, so 0 plus pi is pi. Pi over 2 plus pi is 3 halves pi. Pi plus pi is 2 pi. Then 5 halves pi. And finally 3 pi. And I would calculate the cosine of each of these locations and then subtract 2. That is one way to do it. The other way is I take my unit circle, and where is my starting location? It's at pi. So I'm going to start here. Cosine is at x or y. So you are only going to tell me the x of the location. So give me a second. I'm writing these out because some people may not remember those. Okay, so I'm going to start here. My start got adjusted. This tells me my start gets adjusted, okay? So, starting here, what's cosine? -1. And then I continue around the world. So now I'm here. What's my answer? 0. Oh, I skipped a step, sorry. Hello. I forgot to subtract the 2. So -1 minus 2 is -3. Okay. Now, at this location, my x is -2, -2. Now I'm at this location. My x is 1 minus 2, -1. Okay? Now I'm at this location. What's my x? -2, -2. And now I'm back to my start as always, and that is -3. So 0, -3. Pi over 2 and -2. Then pi and -1. 3 halves pi is -2. So this is one of those pretty symmetrical ones. And it goes like that. Sorry, I missed a dot, but you get it. Okay? So, please attempt number 10. Number 10 has a reflection, but we're just going to treat it as multiplying by -1. So this is -1 times the cosine of yada, yada, yada plus 1. Cool? All right. So you can either do adjust your start or you can do the 3 columns. I don't care which way, but you need to pick a way and start and stick with it. So either 3 columns or adjust your start. I will show, I'm actually going to do adjust your start this time. Okay, I'm back. Here we go. All right, so I've been adjusting my table and doing a 3-column table. This time I'm just going to adjust my start. Again, you will prefer one method and just stick with it, okay? So this says backwards pi. So I'm going to go backwards pi. Remember, each one of these is half of a pi. So boom, boom. So I'm going to start right here. It is asking for cosine. Is cosine x or y? X. So at this exact location, my x value is -1. So I'm going to do -1 times -1. Again, you could do this in your head, but I'm just showing all my work. This is -1 times the cosine of that location. So -1 times -1 is 1, and then they want me to add 1. So that is 2. So 0 is 2. Okay? Pi over 2, pi, 3/2 pi. This first column doesn't change unless it gives me the same answer, okay? Now, I'm just going to go around clockwise now. So I'm going to move forward half a pi. I'm here. What is my x? 0 times -1. 0 plus 1 is 1. -0. My goodness. Okay, now I'm here. What's my cosine? 1 times -1. -1 plus 1. 0. Cool? Now I'm going to move to this axis. What's my cosine? 0 times -1 plus 1. 1. And now I'm back to my start. -1 times -1. 1. It's the same as this, so it's 2. So now I can plot my points. So 0, 2, pi over 2 and 1, pi and 0, 3/2 pi, and back up to 2 pi. Makes a pretty wave. La, 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 la. Make sure you're rounding it, not sharp edges. Cool? All right. So you're going to be responsible for 11 and 12. I'm going to move your definitely. I'm not moving it again. You are definitely having a 4-question quiz tomorrow on this, okay? All right. Please go to number 12. I want to talk to you about number 12. They want me to multiply the angle, not my answer. They want me to multiply the angle by 1/2. So let's watch this for a second. Okay, I'm going to start with 0, pi over 2, pi, 3/2 pi, 2 pi. When I subtract pi over 2, that gives me negative pi over 2, and then they want me to multiply it by 1/2, and that gives me negative pi over 4. Do I like that? No. That's just going to give me an ugly answer. Yes? So I'm going to eliminate that one for now. Because it's going to be the square root of 2 over 2, and then I have to subtract 2 from that, and that's that. And that's not something I want to do. Okay? If it's cosine and it's a 60-degree angle, I love it because that's 1/2. I can work with 1/2. I don't like working with square roots of 2, square root of 3s. You can, as you saw in the previous problem, we just estimated it, but we don't want to do a whole lot of estimating, so we're going to do a different strategy, okay? So now I have pi over 2 minus pi over 2. 0 times a half is 0. Okay, what is the cosine at 0? 1 times negative 1 minus 2. So this one would be a negative 3. So am I going to keep that one? Yes. Now we're going to go to pi. Pi minus a half is pi over 2 times a half is pi over 4. Do I want to work with that? No. All right. 3 halves pi. What's 3 halves pi? Mine half a pi. Mine is half a pi. Pi. Pi times a half is pi over 2. Can I calculate pi over 2? Yes, it's one of my axes. What is the cosine of the northern axis? 0. And negative 1 times 0 is 0. Minus 2 is negative 2. Okay? All right, now we're at 2 pi. 2 pi minus half a pi is 3 halves pi. But then when I multiply it by a half, it's 3/4 of a pi. Do I want that? No. Is somebody seeing a trend? Every other one. Excellent. Good eyes. So now I'm going to do 5 halves pi. What is 5 halves minus 1 half? 4 halves, which is 2 pi, right? 2 pi is right here. What's the answer at 2 pi? It is 1 times negative 1 minus 2, which is what you just called out, negative 3. Okay? Am I going to do 3 pi? No. I'm going to go to 7 halves pi. And I have to keep going because I need how many points? 5 points. Cool? I know, but just make it a pretty curve. If you really want one in between, we can, but I'm trying to make it easy for you. Everyone clear? Okay. So you are doing 11 and 12. That is your homework, and your quiz is 4 of these tomorrow. They won't be anywhere near as tricky as 11 and 12. Okay? But if you can do it, then the quiz should be a piece of cake.